So Ken's actually an economist, which of course, as we know, is part of that equation that needs to come up to the story. And he's been working in GIS and modeling, and brings to the table, you know, how is it that we're going to quantify and value and look at these ecosystem services. Been working with invest models, and we're going to hear from him a little bit more about what all that looks like. So you're up first.
Thanks so much. So I'm going to be talking today about ecosystem service modeling, but some of the considerations that we might want to think about in the age of big data, which is really something that's emerged over the last 5 years, but it's something that just keeps accelerating. And I want to start the story around 2010, 2011. I did some of the first work in this field after grad school, actually working with CISL, on an evaluation of different ecosystem service tools. This was around a time when a lot of tools were emerging to quantify ecosystem services. That's a process that's still happening, but we did really the first comparative assessment of what these tools can do and how they might fit together and how people might choose which one to use. And to do this, we came up with a list of 8 criteria after working with a series of stakeholders and compared all these tools. So this is our starting point because I think some of the new data streams that are becoming available and some of the new computing options that we have for ecosystem services may add a few more of these criteria that we might want to consider in building the next generation of ecosystem service tools. So big data, we all hear about it. It's data that there's a lot of, that there's high variety, and it's coming in really quickly. That's the simplest definition. And I would argue that to understand ecosystem services in an urban environment, there's a whole variety of different data types and sources that we're going to have to figure out how to integrate somehow. And that this imposes some new best practices or design philosophies as we're thinking about how to do that modeling. So what is important here for us to think about in ecosystem service tools? One is that they're open source. One is that, you know, we've got this whole universe of models out there. How do we pick the right one for the time and place and the characteristic that we want to model? In order to do this, this is a point that really gets lost in the noise, but is actually absolutely critical as we have all of these different data and models. We need to be able to label and match these different data sets and plug them into the right places. And the more automated we can make the process, the faster and more replicable we can make our work. So to that end, I've been working over the last 11 years on a tool called ARIES, Artificial Intelligence for Ecosystem Services, that we think does some of these things. So it's a cloud-based modeling system. We're storing data and models on the clouds and linking them. It's collaborative. It's a way to tune and adjust models. And it's what we call context aware. So we can program in different characteristics of models that would work in different places. So we'd expect ecosystem services and how they're provided and used to be different in Phoenix than we would New York or Shanghai or other places. So ways to customize those models and know when and where to use certain data and model elements becomes really important. And really it's not a model itself or a collection of models, but a way to manage and link together data and models. So how does this work? We've got a software interface where it's actually really easy. There's just 2 steps. The first is picking when and where you want to run a model. So dragging and dropping a location and a time and a scenario if you're running a scenario. In this case, this is an example for Maricopa County, where we are here in Phoenix. You pick which ecosystem service you want to model. Similarly, drag and drop that. That calls on the data and the models that are specific to your time and place that you want to do your modeling, assuming that those models are there and they contributed to the system. And we have a set of global models that are available, and then all the rules to customize those to when and where you want to. So I've actually done that, and I'll give some examples for Maricopa County, and was able to do that in an afternoon, which is a process that in the past, could take months and months of work. I should also mention this line on the bottom. This is all within an open source software package where we have a long planned web interface that we're going to be rolling out near the end of the calendar year, and that'll make this even more accessible to decision makers and less technical users. So something that we think is an important step forward for improving accessibility of these models. So what we have in order to customize those models, we've got those global models, but in order to customize them, we've got a really simple web-based tool to upload data to the cloud and to make it available to everyone who wants to use it, or to keep it private if you want to. But I can literally just drag and drop my data set and have it served on the cloud and able to be pulled down for use in ecosystem service models. And for technical modelers, there are lots of ways to customize the models. So this may be a little small for those in the back of the room, but this is a chunk of code that customizes the carbon storage model based on a couple of studies of carbon storage in Arizona. So we've parameterized those, and if you choose to run your model in Arizona, these model coefficients will be pulled versus one in other parts of the world. We have a pollination model where, for instance, we pull in cropland data for the US that if we were running this in Mexico or in South America or in Europe, you might rely on a global layer. In the US, we've got the local data available. So what does this look like? When I ran this FAST ecosystem service assessment for Maricopa County, produced some maps of carbon storage and sediment regulation. These are a little hard to see from the back of the room again, but we have some hotspots along the Salt and Gila rivers where there's remnant forest and wetlands, and those are some of the carbon storage and erosion control hotspots from erosion. We have a map of recreational opportunities out of a recreation model, insect pollinator habitat suitability, and there's a whole bunch of other metrics here that we could have displayed, but this is just one set for each of the ecosystem services, and a curve number based flood regulation model. So in many cases, we've taken some other models that people have developed using Invest and some other tools and coded them in a way that it can be reusable and more easily linked to data. And we've also mapped out supply and demand for many of these ecosystem services. So this can start to get at the question of how generous is a city, or how much supply of ecosystem services within a neighborhood or a sub-watershed or an urban area itself is being generated versus the demand. So once all of this is set up, it takes a couple hours. It's fast because it relies on this big contributed model and database that's sitting up on the cloud. The models themselves, of course, aren't calibrated. This is just an initial run, and that would take a little bit more time and work. But it could form the basis of participatory modeling. You could bring these models and have people work with people to update them, to talk about the places they think are good and need some work. And I think it could shorten the time it takes us to do assessment by quite a bit. So the limitations, one of the big questions is in software development and making sure that there's the resources to have continued software development here. Building the user community. This is the type of setup that will grow and expand if we have the users. If we build it and no one comes, it's sort of going to be a missed opportunity, but we're trying to convince people of the value of collaboratively coding data and models and making this easier for modelers to contribute, using their own programming languages they're more familiar with, providing more simple and user-friendly training opportunities. We need to build out the data labeling and matching system, which is at an early stage. And finally, we have a colleague of mine, Jim Boyd, who's an economist, said that integration frameworks are like toothbrushes. Everybody wants one, but no one wants to use someone else's. So that's potentially a problem. And something we as a community need to decide what's our integration framework, and how do we pick something that will work and has all the desirable characteristics. If everybody used this, I think our data and models could talk seamlessly to each other, and our assessments would be much faster, flexible, and more accurate, and we wouldn't be bound to a particular modeling framework. We'd be able to interchange different types of process models and agent-based models and all other styles of model. And there have been some efforts by the Invest group to compile some of their model coefficients. by some folks out of Europe to compile ecosystem service maps. So there have been a few efforts to centralize some of the data inputs for ecosystem services, but not really using these best design practices that will let the models really integrate, talk to each other, and run fast assessments that are also accurate. So I think there's some real advantages if everybody could get behind a modeling system like this. I'll close. I won't read through these, but based on this work that we've done, I would add to the 8 criteria that we had initially some other design criteria we might consider for ecosystem services in the big data age. So, some criteria related to reusability, data and model sharing, the ability to integrate paradigms, the ability to combine something that technical modelers can use that the decision makers and less technical folks can also find to be accessible, and then to account for supply and demand and flows when we think about urban ecosystem services. So thanks again, everyone, and look forward to the discussion.
Awesome. So Ken is a good example of some of the things that Janine and I struggled a little bit when we were planning this. Of we recognized had this idea of the researchers and tool creators and practitioners and decision makers, but what kind of research? And Ken's got a number of dots. He's like, I'm not just a researcher, I'm also a tool creator, and I think that's really important to recognize. What is the data that we're using, and what are we doing with that data, and what kinds of tools, and who's it serving? Is it serving decision makers? And I would say almost in number 5, powerful enough for technical modelers, easy enough for non-technical decision makers. Compelling enough that the raw research data gets in there, and design ready for the practitioners to work with it and test their design concepts against what comes out of it, right? So this expanding circle of possibilities. So we're going to hear from 2 more people in this research space. One is around looking at how does all of this affect our ability to be resilient in the face of climate change.